Hello everyone. In this lecture, we are going to learn about arrays. In this module, you will learn about single-dimension arrays, arrays of primitive types, arrays of reference types, pass by value, pass by reference, and enhanced for loop statement. Arrays are programming constructs that are useful for grouping elements of the same type. These elements may be processed together easily or processed individually as necessary. The elements of arrays may be a primitive or a reference type. Elements of an array are accessed using the index number of the element. And following the notation from C and C++ programming languages, array indexes start from 0. Array index numbers must be an integer type, and they cannot be smaller than 0. Now in Java, arrays are objects. Therefore, they are reference types. For example, string is actually an array object in Java. An array length can be accessed using the length attribute of the array object. And here is a 6-element integer array. The name of the array is int array, and the last index of the array is 5, and the last index is 1 less than the number of elements in the array, as the first index starts from 0. So this is a 6-element integer array, and the last index is 5, starting with the first index from 0. Let's see how we can declare and create arrays in Java. Arrays are created similarly to objects and using the keyword new. And here's an integer array with 6 elements. First, we are going to specify the type of the array, and using the square brackets, we are going to indicate that this is an array. So this is an integer array. And then we are going to name our array, which will be the reference for this array object. Then we are going to use the keyword new, and then we are going to specify the number of elements in this array. We can also do this in 2 steps, such as declaring the array first and then creating the array. Here are array examples for different types. Now we have a double array with 8 elements. We have a Boolean array with 15 elements. And here is a string array with 20 elements. Now let's look at how arrays are initialized in Java. When arrays are created, Java initializes the array elements to default values unless the programmer initializes them. And here's an example. We have a class called arrayExample, and this class has a main method. Now within the main method, we are creating an integer array with 5 elements. As you can see, we are not initializing this array, so we are leaving it to the Java compiler. Now we have a for loop, and within the for loop, we are going to print the values of the array elements. And we are also seeing the use of length property of the array object. So within array.length, we can get the length of this array, and which is 5 in this case. Here is the output of the program. As you can see, all elements of the integer array are initialized to 0. Because remember that in Java, the default value for integer is 0. That's why the Java compiler initializes the elements of an integer array to 0. Now let's look at another example. We have a class called arrayExample2, and within the class we have the main method. Now within the main, we are actually creating different types of arrays. We are creating an integer array, a double array, a Boolean array, and a string array. Now we are not initializing these arrays to any values, so let's see what the Java compiler initializes these arrays. And we have a for loop, which we are going to print out the first 5 elements of these arrays. Why the first 5? Well, you have used the integer array's length property, which is 5 because the integer array has 5 elements. And then we are going to print out the values of each of these different types of arrays. Here's the output of the program. Now, the elements of the integer array are initialized to 0. The elements of the double array are initialized to 0.0, while the elements of the Boolean array are initialized to false, and the values of the string array are initialized to null. Now we may also initialize the arrays ourselves. So here's an example. We have the class arrayExample3 and we have the main method. Now here's how we can create and initialize an integer array with 5 elements. We are going to use the curly braces, and then we are going to assign a value to each element of this integer array, such as 2, 4, 6, 8, and 10. And then we are going to print the values of these array elements. Naturally, the output of this program would be 2, 4, 6, 8, and 10. Here's an example of how we can initialize a string array. We are going to use the curly braces. Then we are going to assign the value of each string array element, such as John, Isabel, Carlos, Catherine, and Juan. And then we are going to print out these names onto the screen. And here's the output. We can also create an array of objects, and we can initialize the elements of this array. And here's an example. We have a class called color, and the color has a color name and color value as attributes. Now we have the constructor, which we are going to assign the color name and color value passed from the parameters. Here's the driver class for the color class. Now we have the main method, and within the main we are going to create our color array, and we are going to indicate the number of elements in this color array. And with each index we are going to create a new color object and assign the value, the reference to this color array element. We have the black, white, red, and blue. And then we are going to print the values of this color array onto the screen. And here is the output of our program. We had 4 elements in the color array, and here are the values for each element of this color array. In Java, we have enhanced for loop statements. Enhanced for loop statements may be used when there is a simple need to iterate the elements of an array starting from the first to the last. Enhanced for loop statements simplify coding. However, they can only be used when the iteration starts from the first element. Now let's see examples. And here's an example for an enhanced loop statement. And we have an integer array that we initialize, and then we are iterating each element of the array. Now in enhanced for loop statements, we are specifying a local variable such as an array element, and then using this local variable we are going to iterate the elements of the integer array, and simply we are printing out the values of this integer array. Here's another example, and remember we had a color array and we have this color driver class, and we are creating the color array and we are assigning values to the elements of the array. And we can use enhanced for loop statement here, and we can specify the type of the array elements such as color, and here is our color variable, local variable, and we are iterating the elements of the color array. Remember, enhanced for loop statements can only be used when we are going to iterate from the start of the list until the end of the array elements. So in this example, we are actually printing out the color name and color values. In the software industry, as software developers, we spend a great deal amount of time in maintaining software, and this software is generally written by somebody else. Sometimes we spend more time in maintaining software than we do spend time in creating new software. That's why achieving code readability, code understandability, and ease of maintenance is important in developing software. Therefore, we employ certain good coding practices, and one of the practices we employ is specifying an array length as a constant. This helps us to easily locate where we specify the size of an array, so that when we need to change it, we can easily locate it and change it. And then the other portions of the code are unlikely to be affected by this change. And here is how we specify an array length as a constant. We use the keyword final, and then we use the snake naming convention, and we capitalize the letters in the constant name. And in this case, we are specifying the array length as 5, and then we use this array length constant to specify our size of the array. In this example, we simply print out the values of the double array, and remember that if we do not initialize to a certain value, the Java compiler will initialize to a default value for doubles. This is 0.0, and here is the output of this program. Now let's see an example of creating an array with random values. The Java Standard Edition comes with various useful packages, and JavaUtil is one of the core packages in the Standard Edition, and the JavaUtil Random provides us with a random number generator. Of course, first we have to import this class, and then we are going to create our array, and then we are going to create an object from the random class, such as random, my random generator, new random. And here's the loop that we are going to use to iterate the elements of the array. And within the loop, we are going to assign a random number to each element of the array. And we are going to use the method nextInt from the random number object that we have created. And we can specify a range for integer numbers, such as 10, which will give us the range from 0 to 10, excluding 10. Here is the output of this program. As we can see, we are iterating the elements of the array, and we are assigning random numbers, random integer numbers, and we can see that there are zeros and there are nines, but there are no tens. So the nextInt actually provides a range excluding the number that we specify as a parameter. So this will give me random integer numbers from 0 to 9. Now let's look at an important mechanism for programming. And this is not just for Java, this is similar for many programming languages. We pass parameters to methods and functions either using pass by value or pass by reference. And there are certain rules that we have to follow when we need to pass by value or when we need to pass by reference. When parameters are passed to a method, depending on the type of the parameter is passed by value or passed by reference. Primitive types are passed by value and reference types are passed by reference, and this is common to many programming languages. When a parameter is passed by value, if the passed argument is modified by the receiving method, the original value of the parameter does not change. When a parameter is passed by reference, if the pass argument is modified by the receiving method, the original value of the parameter does change. Objects and arrays are passed by reference in Java, and remember that arrays are also objects in Java. When we pass a parameter by value, we are actually sending a copy of the value. So what happens to the copy will stay with the copy. It will not affect the original value. That's why we call it pass by value. We are just passing the value, not the original reference to the parameter. In programming, when we pass a parameter by reference, we are actually sending the address or the memory location of that piece of data or object. So in the receiving method or in the receiving function, when the value of that parameter is changed, it's modified in its original memory location. So the modification will stay the same for all the scope within the program. Let's look at an example for pass by value. We have a class called pass by value example. Within this class, we have two methods, such as a main and the modify value method. Now within main, we have a local variable called parameter, which is an integer type, and we initialize this variable to 5. First, we are going to print this value. Then we are going to send this variable to modify value method. Then we are going to print the value again, and we are going to check whether the value of this local variable has changed or not. And within the modify value, we take this as a parameter, and then we multiply it by 2. And then within the modify value method, we are going to print the value. Here is the output of the program. Before sending the parameter to the modify value method, we are printing its value, which was 5. Then we send this parameter to the modify value method, but actually we are sending the copy of that parameter. So what we modify will not affect the original value of this parameter. So when we return back to the main method, we are going to see that the value of the parameter stays the same. So in pass by value, the original values of the parameters do not change. Now let's look at an example for pass by reference. We have a class called pass by reference example. Within this class, we have two methods, such as a main and a modify value method. Within main, we are declaring an array and initializing this integer array. Then we are going to print the values of the array elements. Then we are going to send this array as a parameter to the modify value method. Then we are printing out the values of array elements and see whether these values have changed or not. And within the modify value method, we are going to multiply the values of array elements by 2, and we are going to print out the values. Here is the output of the program. First, we are printing the values of the array elements. Then we are sending this array to the modify values method. And within this method, we are actually multiplying the values by 2. But when we return back to the main, we are going to see that the values that's changed within the method actually stays the same. So when we send an array to a method, we are actually sending its reference. Remember that arrays are objects in Java. Therefore, when we change the values in a method, that will be within the scope of the program. So what we modify will stay as modified. Now let's briefly overview exception handling in Java. Exceptions are events during program execution that disrupt the normal flow of the application. In software development, the term happy path is used to denote the execution paths that end with the expected result of the application. Simply, in happy paths, we only expect normal flow of operations and do not expect exceptions or faults. A good programming practice is to design our applications as fault-tolerant. In designing fault-tolerant applications, developers consider the cases leading outside the happy paths. Therefore, designs are hardened with mechanisms to handle exceptions or faulty cases. How the exception will be handled depends on the need. We are going to look at a simple example for exception handling. We have a class called arrayExample, and within this class, we have a main method. Within the main, we are creating an integer array with 5 elements, and we are initializing this integer array. Then we are going to print the values of array elements. Now, for the sake of the example, we are trying to reach the 6th element in this integer array. But remember that there is no 6th element because this is an array with 5 elements. Of course, we know this will create a problem, this will create a bug, but our goal is to show how we can utilize exception handling. Now, in Java, we have an array index out of bounds exception. So this is used for these kind of cases when we are trying to reach outside an array boundary. Then we are going to create exceptions such as array index out of bound exception. And we put this code into a try catch block. And within the catch, we specify the type of exceptions that we expect. Now, this is a simple example, but in reality, we may expect a number of different exceptions, and we may list all of these. And also, we may do some certain manipulations for an array that we may not be sure whether we are reaching outside the boundaries of this array. And then we are going to print the exception, and we are going to print that we are trying to attempt to reach the sixth element of the array. Here is the output for the program. Remember that first we are printing the values of elements in the array, and here are the values of the elements in the array. Then when we try to reach the sixth element, an exception will be created, and the compiler will warn us with the exception. Actually, we are printing this exception. So this is what the compiler will print for us. And then we put a notice about saying that we are trying to attempt to reach the sixth element of the array, which actually created an exception. Here's an exercise for you to practice arrays and simple exception handling. First, create arrays of primitive and reference types. Access the elements and modify their values. Then, add necessary exception handling code to handle array index out of bounds exceptions. Of course, if you are not trying to reach an outside the array, so you will not able to create the exception, so just code something that will create these kind of exceptions, and then you'll practice exception handling. And this is the end of this module.